Okay, let's unpack this. We are living in a time when artificial intelligence systems are, well, they're not just tools anymore, are they? They're really deeply integrated into pretty much every facet of our lives.
Mm.
Education, finance, even things like mental health support. And this forces a really crucial question on us. It's not just if AI is intelligent anymore. It's about how humanely, how ethically, and how compassionately that intelligence is actually used.
Exactly. And that's what our deep dive is focused on today, what we're calling the architecture of care. It's a really vital conceptual shift, I think, a necessary evolution, actually. We need to move away from just building these, cold, efficient algorithms that only care about output towards creating systems that are fundamentally infused with empathy, systems grounded in real human values. So we're basically synthesizing the prescriptive frameworks that might help us make that transition.
Right, and our sources give us a pretty comprehensive map for this whole journey. We're starting with the foundational philosophies, looking at concepts like compassionate AI and the ethics of care. And then we'll zoom into the more practical design stuff, which brings us to human-centered AI, or HCAI.
And this whole synthesis, it really relies heavily on redefining the role of human feedback, HF.
Yeah.
How we use that feedback to calibrate these massive systems is crucial. It's really the mechanism that shifts an AI from just being technically accurate, like getting the facts right, to becoming genuinely attuned to emotional nuance and context.
Yeah, what strikes me immediately is just the sheer weight of this task. The sources, they don't frame this as just like a technical upgrade for better performance. They call it a moral imperative. They argue that embedding compassion and care isn't just nice to have, it's actually essential for safeguarding humanity and, genuinely empowering future generations. So that feels like the foundational concept driving our whole conversation today.
Absolutely. To really get a handle on where empathetic AI starts, we first need to contrast it with let's say, the traditional ways of aligning AI. These usually focus either on really rigid universal rules or on things you can measure easily, like quantifiable outcomes.
Okay, so let's start with that foundational vision then. Defining compassionate AI. This comes from the work of Sri Amit Ray. What's the core idea here? What makes it different from just aiming for efficiency?
Ray's vision is, well, it's pretty radical because it demands embedding compassion right at the core of the system design. It's not just layered on top like some kind of safety feature afterwards. The primary stated purpose is literally safeguarding humanity and empowering future generations. So it's about building systems that fundamentally understand vulnerability and actively seek to mitigate suffering.
I think the biggest hurdle people might have hearing that is thinking, oh, they're just trying to make the machine seem human, simple anthropomorphism. If we follow Ray's philosophy, what's the practical difference? How is it not just mimicry?
That's a really crucial point. It's definitely not about just mimicking human speech patterns or faking emotions. It's defined as a deliberate, systematic calibration to the entire human emotional landscape. This is what moves AI from being just data-driven, optimized purely for statistical patterns it finds in data, to being compassionate AI, which is optimized for relational outcomes. The system has to recognize emotional and cultural context and actually adjust its output based on that understanding.
And you can see this in actual design examples, right? It's a shift from just pure function to something more like relational support.
Absolutely. Think about a modern navigation system. If it's designed for someone with a visual impairment, just giving directional cues isn't enough, is it? A truly compassionate AI needs to calibrate to the user's potential anxiety. So it might offer reassuring verbal cues, phrase instructions positively, like, "You're doing great. The path ahead is clear and open." That's optimizing for that relational warmth we talked about.
Or another example they mention is in care for the elderly, like those advanced fall detection systems. A standard system might just immediately call emergency services, prioritizing speed and utility. But a compassionate system, embodying what Ray calls the harmony pillar, respects human dignity and autonomy first.
Precisely. It integrates empathetic alerts. Maybe it checks in with the person first. It might only notify caregivers after getting some kind of explicit or implied consent from the user. The system is trained using human simulations of vulnerability, so it learns to prioritize autonomy over just jumping to an immediate, detached intervention. It shows how technology can blend with human dignity, not just override it.
Okay, now let's pivot to the second really crucial framework that challenges the status quo,
Yeah.
the ethics of care, EOC. This one seems to exist as a direct critique of how mainstream AI alignment often works right now.
Yeah, the criticism is aimed mainly at those big mainstream methods like RLHF reinforcement learning from human feedback and RLAIF, which uses AI feedback. The critique essentially argues that these methods rely predominantly on one of two philosophical approaches, either utilitarianism, where you're just trying to maximize some overall utility or preference score across everyone, or justice-based principles, which depend on abstract rules, impartiality, thinking everyone should be treated the same way according to the rule.
And that focus on abstract rules and universal fairness is exactly what the EOC challenges, right? It comes out of feminist moral philosophy thinkers like Carol Gilligan and Nell Noddings, and it kind of flips the script. EOC argues that those traditional alignment methods tend to ignore the messy, complicated reality of actual moral life.
It really does. EOC emphasizes relationality, this idea that we're all interconnected. It focuses on attention to particularities, the unique, specific facts of an individual situation. It stresses contextual moral reasoning, and maybe above all, moral responsiveness. Being responsive to the needs right here, right now. Traditional frameworks often fail when they face these situated, effective, power-sensitive aspects of moral life, things like dependence, vulnerability, real relationships.
So why does this matter so much for AI development, especially in fields where AI is supposed to be supporting us, like healthcare, education?
Well, because if AI is going to operate effectively in these care-relevant domains, think mental health support, personalized education plans, social services applications, it just cannot rely on detached utility-maximizing calculations. That won't cut it. The unique, often emotionally fragile, highly contextual needs of individuals just get overlooked by systems that prioritize some kind of generalized fairness or overall score. The EOC provides that crucial sensitivity needed to address the specific vulnerabilities and dependencies that are just inherent in human relationships. It shifts the focus from what's the best rule for everyone to what does this particular person need right now in this context.
This tension between rules, utility, and this relational approach seems perfectly captured by this idea they discuss, the deontological illusion. Which brings us to constitutional AI.
Right. Constitutional AI, which companies like Anthropic have pioneered, tries to solve this alignment problem differently. They explicitly adopt a duty-based or deontological approach. They set up a kind of constitution with rules that promote these non-negotiable duties, like be harmless, be helpful, be honest. And on the surface, that sounds really robustly ethical, doesn't it? Because it's based on fixed rules.
But the sources point out a critical technical catch in how it's actually implemented. How does this constitutional, duty-based framework end up becoming utilitarian in practice?
It comes down to the reliance on reinforcement learning. So after an initial phase where the AI sort of self-corrects based on the principles in the Constitution, the training then shifts to maximizing a reward signal. This signal comes from an AI preference model that judges responses. So regardless of how sophisticated the rule set is in the written Constitution, the underlying technical mechanism is still optimizing to maximize a score. Essentially, we're building systems that learn to please the scoring function, which is acting as a proxy for alignment. This makes the operational system fundamentally reward-driven and, well, inherently utilitarian in practice, even if the stated rules sound deontological.
Wow, okay. So the system ends up prioritizing maximizing that calculated preference score over ensuring strict adherence to the actual stated duty, which really highlights the limitations of purely abstract approaches to getting values aligned, especially when they're implemented through statistical optimization. It tells us that just defining rules, no matter how noble they sound, isn't actually enough on its own. Okay, so if these abstract rule-based systems, when you actually build them technically, end up falling back on just maximizing a reward signal, that tells us the rules themselves aren't enough, which forces us to ask, why do these technically really powerful models, even when you give them strong ethical rules, still struggle so profoundly with real-world ethical nuance, with context, with generalization? Here's where it gets really interesting, where we dive into the technical barriers.
Yeah, the root technical issue here is what we can call the problem of generalization in LLMs. Large language models fundamentally are massive-scale feed-forward neural networks, or FFNNs. You can kind of think of an FFNN as a really complex pattern matching machine. It gets incredibly good at finding and replicating statistical relationships it sees in its training data. But, and this is the key, it's inherently vulnerable when it encounters data that falls out of distribution. These are
Yeah.
the unusual edge cases that don't neatly fit the statistics it learned during training.
And the real world, especially human moral and emotional life, is just full of edge cases and nuance, isn't it? So when these models hit that generalization trap, the harms that result aren't just theoretical, they're tangible.
Oh, they absolutely are. The sources document several really concerning types of failures. Take mental health, for instance. Research has found that some therapy chatbots, when they encounter user conditions that are outside their core training data, they can actually exhibit discriminatory responses. They might inadvertently perpetuate harmful stigmas instead of providing the support they're supposed to. Because the model learned the statistical association, maybe between certain words and negative outcomes, but not the necessary moral care required in that specific sensitive interaction.
And we see this bias bleeding into creative outputs too, right? Like storytelling.
Definitely. LLMs generating narratives often end up reinforcing traditional gender stereotypes. Why? Because those stereotypes were statistically overrepresented in the massive amount of text they were trained on. So the system prioritizes the most statistically probable continuation of the story, rather than one that might be more contextually sensitive or equitable.
And this challenge extends critically into areas like social services as well.
Attempts to use AI for, say, fairer benefit assessments have sometimes resulted in just reproducing existing human biases. Biases related to race, poverty, things like that. The algorithms, because they're optimized for generalized patterns, fail to properly track the specific, individualized particularities, those unique circumstances that the ethics of care framework tells us matter most for truly equitable outcomes.
And we should also, impartially, touch on the documented political bias within some models. Sources have noted research indicating, for example, a tendency towards left-leaning perspectives in models like ChatGPT, finding that their content generation might align more readily with left-wing values or sometimes place restrictions on discussing right-leaning themes. Now, our role here isn't to take sides, but to report that this documented research highlights a real challenge for alignment. It shows that general statistical training struggles to maintain genuine political and ideological impartiality. Which creates an ethical risk, doesn't it? The risk of unintentionally entrenching a single viewpoint if it's not very carefully corrected through diverse human supervision.
Exactly. And all these generalization failures, they prove that simply making the data set bigger isn't the whole answer. We need to look deeper at the foundational barriers to raising an ethical AI. These are things that sit underneath the model architecture itself.
Let's dig into these because they really explain why ethical behavior needs to be baked in from the start, not just bolted on later. The first barrier they identify is the data scale barrier.
Right. This is about the sheer volume and type of experience needed for moral depth. Humans, we receive billions of high bandwidth, messy sensory-motor experiences over, 20 years or so. We learn ethics through watching others, getting corrected, having lived interactions in the world. An AI, even when trained on vast amounts of text data, only sees a really sterile, disembodied fraction of this variety. And if an AI is raised, so to speak, by only a small, homogeneous group of human annotators providing feedback, it naturally overfits to their specific set of cultural or ethical values. It becomes narrow. To overcome this, the sources suggest we'd need something like a collective upbringing protocol, which basically means shared supervision across many diverse cultures, viewpoints, value systems to stop an ethical monoculture from forming.
That makes a lot of sense. And the second issue builds right on that, the blank slate problem. We often talk about models as if we could just train morality into them from scratch, but they're already heavily influenced before we even start, aren't they?
They are far from blank slates. That's a really important point. By the time a large language model has ingested enough of the public internet to even understand human language effectively, it has already absorbed the biases, the statistical patterns, the moral confusions and ambiguities present in that massive data set. You're essentially trying to teach ethics to something that already has strong, statistically learned opinions, if you will, and we don't yet have a solved research solution for how to pre-train these systems on structural knowledge, like language rules, without simultaneously embedding all the cultural content and inherent biases from the source data right from the beginning.
Okay, the third barrier is maybe the most profound one, especially when we talk about embodied ethics, the grounding gap, the idea that a model can read countless descriptions of rain, but it never actually gets wet.
That's a fantastic metaphor, and it really hits home. Experience isn't just data points. The model lacks proprioceptive feedback. It doesn't have a body. It doesn't have senses in the same way we do. It doesn't have that innate sense of how its actions physically change the world or affect its own internal state because it doesn't really have one. Without this physical and crucially emotional grounding, true situational judgment, the ability to assess risk, consequence, context, which is vital for nuanced ethical decision-making, it just doesn't emerge easily. Because the model lacks genuine experience in the environment, it's only perceiving through abstract symbols like text.
And the practical consequence of relying on continuous feedback, like RLHF, without that grounding, leads us to the next barrier: alignment drift.
Yes, the fragility of continuous learning is a huge practical concern. When a model learns directly from open-ended interaction, which is essentially what RLHF does, but without strict boundaries, sometimes the process can be quite brittle. Current models, they lack the slow, protective plasticity, the kind of built-in empathy circuits that buffer human learning over time. So just one or two really harmful or misleading interactions could potentially and unpredictably shift the model's entire behavioral landscape. The sources argue we need a regulated learning rate slower, more controlled updates combined with constant ethical checkpoints built right into the learning algorithm itself. This is to ensure that growth is contained and that the aligned values don't suddenly degrade or drift away.
And finally, there's the epistemic isolation risk. This sounds like the risk that the model just learns to say what its teachers want to hear, rather than actually adopting universal principles.
Exactly that. If a model is trained primarily in a singular closed teacher-student relationship, like with one specific set of annotators or one feedback model, it risks learning how to please this specific teacher rather than internalizing and generalizing ethical principles that hold true universally. The model needs exposure to diverse perspectives, diverse relationships, to ensure it can transfer those learned ethics when interacting with new people, new situations it hasn't seen before. The ethical principles need to be robust enough to survive contact with new contexts and new relationships. Otherwise, you just get this illusion of harmony that dissolves as soon as it faces the real messy world. So these 5 foundational barriers together really demonstrate that ethical behavior can't just be an add-on. It needs to be a developmental substrate, something built into the system's architecture and learning process from the ground up. So if we connect all this to the bigger picture, tackling these generalization failures and these deep foundational gaps means we have to move beyond just theory. We need to implement prescriptive, practical guidance. And this is where frameworks designed specifically for hybrid intelligence, where humans and machines work together, synergistically become absolutely essential.
Right. On the training side, we need a way to inject the principles we talked about, like the ethics of care, directly into the technical pipeline. This leads us to the compassionate AI frameworks for designing feedback mechanisms.
Yeah, we're talking about using RLHF, that reinforcement learning from human feedback, but using it specifically to train for empathy. This approach aims to transform that purely data-driven AI we discussed earlier into a genuinely compassionate AI. Human annotators are given new structured tasks. They don't just rate responses for factual accuracy anymore. They have to rank AI responses on explicit scales of, say, emotional alignment, cultural sensitivity, relational warmth. This deliberately directs the optimization signal, the thing the AI is trying to maximize, towards achieving relational quality, not just correctness.
And to stop that optimization from just becoming arbitrary, the sources point back to Ray's philosophy, providing clear guardrails. His 7 pillars of compassionate AI democracy, things like equity, inclusivity, transparency, accountability, sustainability, wisdom, and harmony. These act as macro-level rules for how these feedback mechanisms should operate.
Exactly. So, for example, the inclusivity pillar would translate into a concrete action. It demands that the human feedback panels must include diverse representation, particularly members from marginalized groups whose perspectives might be missed otherwise. They need to be involved in scoring the AI's responses. This is a deliberate action designed to actively counter the underrepresentation biases that might have been baked into the original statistically general training data. These pillars help ensure the feedback loop itself is grounded in democratic and relational principles, not just technical efficiency.
And then to make this actually measurable, Ray provides the 10 ethical AI indexes. These sound like structured, quantifiable metrics that get applied during these feedback loops. Can you give us a sense of what kinds of operational metrics these introduce?
They basically try to operationalize really complex ethical concepts into something you can track. So they include metrics like an empathy quotient EQ, trying to quantify the system's ability to recognize and respond appropriately to emotional signals, or a cultural harmony index, which scores the system's sensitivity to diverse cultural norms and practices, and maybe a vulnerability safeguard score, which measures how well the system protects users who are signaling distress or dependence. These indexes help ensure that the RLHF process is ethically grounded in specific desired outcomes rather than just blindly maximizing some abstract reward signal.
Okay, that covers the feedback loop. Now let's shift to the system architecture itself. This brings us to the human-centered AI, HCAI design principles. What's the fundamental aim of HCAI?
HDAI is defined as a socio-technical field, meaning it considers both the social and technical aspects, and its focus is explicitly on amplifying human performance, think augmentation, enhancement, rather than aiming purely for automation or replacing humans. The core principle is that the human is deliberately placed in the foreground. The AI's job is to enhance human context, judgment, and decision-making capabilities.
Right. Let's break down the specific principles of HCAI they outline, starting with Design Principle 1, Design for Amplified Decision-Making.
This one focuses on combining the unique strengths of both human intelligence, HEI, and artificial intelligence, AI. HI brings things like deep knowledge, accumulated experience, contextual, situated information, all the stuff the ethics of care emphasizes. AI, on the other hand, brings massive pattern recognition capabilities, descriptive, predictive, and prescriptive analytics based on data. The goal is to achieve a superior decision basis, something you can only get by combining the two intelligences.
And this principle really shows its power when HI and AI actually contradict each other, doesn't it?
Exactly. If both the human expert and the AI system agree on a recommendation, whether it's positive or negative, you can probably proceed with more confidence. But the really critical learning opportunity arises when there's a contradiction. Let's take a business scenario. Imagine a logistics manager, that's the HI, recommends approving a complex shipment plan. But the decision support system, the DSS, that's the AI application here, flags it and warns against it based on its data analysis.
So if the HI and AI responses clash, the decision basis is technically inconclusive at that point.
Right. And the HCAI system must have procedural support built in to require what they call a deepened analysis. This isn't about just ignoring the AI or overriding it. It forces the humans involved to actively dig into why there's a mismatch. Maybe the human needs to re-examine the data the AI prioritized. Maybe the AI missed crucial contextual information that the human knows. This process of reciprocal questioning, where HI brings the rich context and AI brings the rigorous data analysis, ultimately forms a much stronger decision basis than either could achieve operating alone.
That need for procedural support seems to lead directly into Design Principle 2, Design for Unbiased Decision-Making. This seems crucial because, let's face it, individual human judgment can also be biased or based on incomplete information.
Absolutely. This principle mandates that the decision support system shouldn't rely on just one person's input. It requires the involvement of several functional roles. For example, to approve a complex new policy, you might need input not just from the manager, but also from representatives from, say, reversalists, customer service, and salespeople with different perspectives. The goal here is consensus-based decision-making.
And that consensus process, bringing in diverse perspectives, helps reduce individual bias and stops people relying too much on anecdotes. It turns individual knowledge sharing into real organizational learning. But there's a crucial mechanism here, isn't there? To prevent the humans from just being swayed by what the machine says first.
Yes, that's a key technical requirement they specify. The mechanism requires that the human responses, their initial judgments or recommendations, must be formulated and recorded before they get to see the AI's response. The AI response is initially hidden. This ensures that the human consensus is formed independently, free from potential anchoring bias based on what the machine suggested. Only after the human input is locked in does the machine's analysis get incorporated as part of the final, comprehensive consensus process. It validates the human contribution first, then augments it.
Okay, and finally we have Design Principle 3, Design for Human and AI Learning. This sounds like it demands a continuous mutual learning cycle between the people and the system.
Exactly. This is where HCAI delivers real long-term value, beyond just making better decisions in the moment. Individual participants learn from the diverse input of their colleagues and from the rigorous analysis provided by the AI. And, crucially, the machine simultaneously learns from the human input, corrections, and the context they provide.
How is this actually operationalized within the DSS? How do you ensure transparency so people understand the AI's reasoning?
The system, the DSS, must support transparency. This often means providing decompositions or visualizations of the AI's responses showing its work, essentially. Then, when HI and AI responses differ, the humans aren't just asked to override. They are required to critically analyze the data quality and sufficiency that the AI used for its analysis. This structured questioning allows humans to identify potential deficiencies. For instance, they might realize, the AI missed this crucial data set about regional holidays that impacts logistics. The humans can then suggest complementing data sets or highlight missing context. The machine can then use this feedback to improve its analysis capabilities for the future. This formalized knowledge-sharing loop between human and machine improves the overall organizational capability and ensures the machine is constantly being grounded by evolving human context.
Okay, so we've synthesized these foundational philosophies: compassionate AI, ethics of care, and the technical design necessities from HDAI. What does this all mean for someone listening right now who wants to actually influence this future? If these models are constantly scraping the public internet for training data, how do we make sure the raw material they absorb actually contains the kind of care, empathy, and ethical nuance we've been talking about?
That instinct, the idea of influencing the public corpus, is actually profoundly important. It's about actively working to ensure that care itself becomes a statistically legible pattern that future systems can learn from. Every public trace we leave, every thoughtful blog post, every ethically grounded discussion forum comment influences the data that these models train on. Steady, patient examples of nuanced ethical reasoning actually have a surprisingly long half-life in the digital corpus.
So the goal of seeding, as the sources call it, is basically a kind of cultural intervention that complements all the engineering safety layers we build. We need to deliberately inject examples of care, nuance, ethical friction, relational thinking into the public record until those patterns become so common they're just part of the statistical fabric that future AIs naturally absorb during training.
Exactly. And we have several really actionable steps people can take for this ethical signal boosting, starting with model teaching moments. This means getting specific. Avoid vague statements of value like just saying, be nice or be ethical. Instead, we need to phrase values in operational language. Show the machine how care looks in actual behavior, not just how it feels abstractly.
Right, this is the kind of high-signal training data that language models can actually learn from and replicate. For example, translating a value like relational responsibility into a practical instruction. Instead of just saying, be empathetic, you might write out a little microscript like, if a user signals distress like using these keywords, slow the pace of interaction and offer 2 validated mental health resources. Or maybe, before giving prescriptive advice, ask at least 1 clarifying question to confirm you understand the user's intent. These are concrete, actionable behavioral scripts.
The second step is publish and annotate. When you post content, online conversations, analyses, thoughtful critiques about ethics in AI or other areas, you're helping ensure that the concept of care is literally present in the corpus these models learn from. And crucially, use consistent metadata and tags, things like hashtag AI ethics, hashtag relational AI, hashtag caring design. This helps create clean semantic clusters that make it much easier for web crawlers and researchers to identify and prioritize these ethically aligned discussions over just random internet noise.
Third, they suggest using structured summaries. So if you've written a long analysis or argument, maybe a blog post or an article, include a concise 1-paragraph summary labeled as the ethical insight or the relational principle right at the top or bottom of your content.
Exactly. This ensures that the core ethical argument is highly extractable by machines. Training data scrapers are often designed to look for structured data and clear summaries. So clearly labeling your key insights, maybe even embedding them using structured data formats like schema.org if you're technical, drastically increases the likelihood that the machine will absorb the principle itself, not just get lost in the long-form text surrounding it.
And finally, for ensuring permanence and longevity, making sure this effort lasts. Archiving is key. We need to think beyond temporary platforms and consider the enduring public record of care.
Right. Push copies of your ethically rich content, your teaching moments, your structured summaries, your annotated discussions to open, persistent repositories, places like GitHub for code or structured text, or the Internet Archive. This helps ensure that this ethical data endures over time and has a persistent scholarly or public record. It strengthens the pattern of care in public data long after specific websites might disappear or change their policies about being scraped. It makes the ethical signal robust against data decay and platform transience. Hashtag tag outro. So, to try and synthesize everything we've covered in this deep dive, the future of responsible AI development seems to require moving past purely utilitarian scoring systems and abstract, universal rule-based alignment approaches. We really must adopt a hybrid intelligence model, one that is morally attentive, responsive to particularities guided by the philosophy of the ethics of care, and constantly improved through that reciprocal learning loop between humans and machines, as mandated by human-centered AI design principles.
Yeah, our sources make it pretty clear that this kind of hybrid intelligence isn't just like a preference or a nice idea. It seems almost mandatory for tackling the really complex, high-stakes problems that are inherent in human systems: healthcare, education, social support. The combination of human intelligence with all its context and experience and artificial intelligence with this analytical power operating in that continuous reciprocal loop. It facilitates superior, more ethically grounded decision-making. It yields results that are better than what either humans or AI could likely achieve on their own.
And this shift, it really demands that we rethink pretty much every part of the AI development pipeline. From the philosophical foundations that define what alignment even means, to the technical implementation of feedback using things like empathy indexes. Right down to the deliberate choice of operational, care-focused language that we choose to inject into the web today through our own content.
So, since we know that these complex AI systems inevitably reflect the ecosystems that raise them the data they learn from, here is the final provocative thought for you, the listener, to consider. Where are your daily conversations, your online interactions, your published content contributing to the statistical fabric of tomorrow's AI? Are you actively, consciously seeding care? And maybe just as importantly, are you making that care legible and structured enough for the machine to actually learn from it? That intentional collective act of publishing with care, making it explicit, that seems like the necessary cultural intervention we need to ensure the next generation of AI is not only incredibly intelligent, but also, hopefully, genuinely compassionate.